Hi class, welcome to lesson 46 on solutions. Today we're going to describe solution concentration qualitatively as dilute or concentrated, and quantitatively we will calculate solution concentration in the unit called molarity. Make sure you have a Regents Chemistry reference table and a calculator out so that you can follow along. Concentration is the measure of the amount of solute dissolved in a solvent. We can describe concentration both qualitatively and quantitatively. Qualitatively, when we describe concentration, we will use terms such as concentrated or dilute. Quantitatively, we can describe concentration as molarity, parts per million, or percent composition. In this video, we will focus only on molarity in the quantitative calculation of concentration. When measuring concentration qualitatively, we can use the words dilute or concentrated. A dilute solution has a comparatively small amount of solute, meaning it has a low amount of dissolved aqueous ions in solution. A concentrated solution is the reverse. It has lots of solute or many dissolved ions in solution. Since qualitative descriptions can be relative, it is best to use quantitative descriptions. Today, we are going to learn how to calculate molarity. In a future video, we will discuss how to calculate parts per million. There are other units for concentration, but we won't use them in this class. Molarity is defined as the number of moles of a given solute in a liter of solution. This equation is found on reference table T. It is a pretty simple equation to use. Now, when molarity has a large number, it is considered concentrated. While when the molarity is a small number, it will be considered dilute. Looking at the very back of your reference table on reference table T, you will see that the equation for molarity is given. This is a fairly easy equation to use, but sometimes you'll also have to calculate moles like we did in the last unit. Remember, moles is mass over gram formula mass from your periodic table. This molarity calculation together. Here we're looking for the molarity. On reference table T, we know that molarity with a capital M equals moles over liters. And here we are given the liters and we are given the moles. So what we'll do is we'll substitute. Molarity is equal to 3.3 divided by 1.8. All we have to do is put this in our calculator, and we'll see that our molarity is equal to 1.83. Let's do this molarity calculation. Here, we're looking for the moles that are in 1.7 liters of a 0.35 molar. So we calculate this capital M as molar solution of sodium hydroxide. So again, we know that molarity is moles over liters. And in this case, we're given the molarity. From here, we can solve with cross multiplication. And you can see our calculated result is 5.95 moles. Now let's try a more complicated problem with molarity. This is advanced, where we're trying to find the molarity of a solution that has 6 grams of Epsom salt in 3 liters of solution. The first thing we'll have to do is calculate moles. So we're going to divide the given mass by the gram formula mass of magnesium sulfate. Now that we have the moles of magnesium sulfate, we're going to take that value and substitute into the molarity equation from reference table T. So here is the substitution, and we'll use our scientific non-graphing calculator to calculate the molarity as 0.016 molar. Molarity always has a unit of capital M, and its unit is always read as molar. Here is one more advanced problem set. Here we are looking for the grams of potassium hydroxide. You can see that we are given the liters and the concentration in molarity. Substituting into the molarity equation, we can calculate moles of potassium hydroxide. But the question is asking for grams of potassium hydroxide. So we're going to have to take our answer and substitute it into the mole calculation. So we know that the number of moles is equal to the given mass over the gram formula mass. Now we can see that 28 grams of potassium hydroxide is needed. This concludes Lesson 46, Part 1. See you in class.